So we jump to the next step, which is either if the collective is, if we need positive pitch, if we move the swash plate upwards or downwards. For leading control, when the ball is in front of the blade, we have the swash plate going up for positive pitch, and this is default on this one. So that's okay. Then we go to the servos, and now is the first time we're gonna check if the servo is going the correct direction here. And we can see that my aileron servo is going correct, but the elevator is going wrong. So then we just press the servo and execute reverse, and let's see, that looks good. Right, left, forward, back, that's okay. So then we go next. Now we need to level the swash plate, and there is different tools. You can pull the head off, you can eyeball it, and for bigger helicopters there is a really good tool I like that is like this. I can fit it underneath, but it don't fit on this small one. So I'm gonna eyeball this one. I really recommend using some tool, because even if you have a gyro on board that's gonna help you, setting it up perfect will mean the difference between if I use a swash level lever and then get it perfect. I don't need to do an auto trim flight. It's gonna fly perfectly from the first time actually. So a little back and click left. Okay, then that we're done. So on here we have a expert screen for you that has the pro version, where we can level it at the bottom and at the top. Actually this one needs a little back on the bottom and left as well. Back. Okay, so continue. Now we have the collective travel, and that's how much collective we have, collective pitch. You can either use a pitch gauge, if you have one of those digital, I use for the bigger helicopters, it's one method. But V-Bar people has another method that you can use, and you don't have to use any pitch gauge at all. And that's by entering the blade length you have. In this case it's 350mm blades. And what I need to do is to fold the blades sideways, like this, and make sure I have center pitch at my radio 50-50. Here we can actually see that I should probably go back and fix my center. I'm going back to the swash and fixing so my center is good. The blade should be the same height here. So back to next, and the expert screen. What we're doing right now is we're gonna measure with a one of these that has, this has legs. They're running away. Some amazing ability to have. Always disappearing when you need one. So what I'm gonna do is, if I lower the collective to minimum and then measure the distance between the blades, I'm getting 177mm. And if I enter this number in here, 177, sorry about that, I can see I have 14.65 degrees pitch, and that is a bit much. So I want to lower that to, let's say, let's try 16. 160. Then we have 13, and that's what I want to run on this. So this is how you use this to measure the pitch. Actually, I'm gonna adjust a little bit so you can see better here what I'm doing. I'm measuring between the blades like this. So then we go to next, and now I'm gonna measure the cyclic throw, and it's the same principle. If you go in, you can either use a pitch gauge, or we can do it this way. Now, if you have a big helicopter, the blades are so heavy, so you can get some a little bit misreading here, but what you can do then is lay down the helicopter on the side so the blades are free, hanging free. In this case, on this little helicopter, the blades are so light so it doesn't matter much, but on a bigger helicopter you can do that instead. And what we need now is the two things. One from position 1 from the table and down. So I need to know from here down to the table. So let's see here, it's 287, and I just make sure it reads same number here, 287, and then we position 252, and that gives me a recommended gain of 72. So now we can see that I'm a little bit outside the range for what's optimal, and that is a problem on this helicopter. I won't get it perfect, so either I have to re-drill the holes and get them either further in, but I know it's gonna fly okay. So the final step we have here is the tail, and first thing you want to do is choose the correct servo type in the program here, where it's important, because if you start to move the servo it will overdrive it if you have the wrong servo type. So choose the correct one for your servo type. Then I want to check if the servo is moving the correct direction. I press let's see if we can get a better view of this. Left stick, right stick, it looks good. And endpoints I can adjust here as well, and I move fully, and the other one is good, and in the other direction is good as well. As you can see, I'm quite low. This is normal for this small helicopters. On a bigger one you probably end up with 55 or 60 even, or something like that. So now we're done, and we press finish, and then we can check. The first thing, can check the sensors, and if we do it like this, let's see here. As I said in earlier episodes, I always put a finger on. It's easier to feel the helicopter movement or the swash movement than actually seeing it sometimes. So I can feel it counteracting every move. Then I check the tail, and that's counteracting the move of my what I'm moving it. So that's okay. Sensors are good to go. Then we can set the parameters of the main screen here. Medium style of flying. Precise is more robot feel. Vivid is more paddle feel. I like medium. Agility comes up a pop-up saying 90 for 3D flight. I like that one, so I'm gonna keep that one. Here we have the gyro gain for a main rotor, and it's basically on size of helicopter. So for small 450s down here, TDR is a 90. I run all my 90 size helicopters at 70 to 75. and logos about 90. You can try around, but general I use those values, it works well. Yaw rate, pyro rate, I'm gonna run quite high, I like it. And tail gain, I'm gonna start with 60 here as a starter, also 450 setting, so to speak. So this helicopter is now ready for a test flight. I will come back to looking into the advanced parameters, but first of all I want to test it and see it works okay, and it should be good to go.